All right, today we're doing areas of sectors, section 20.3. So a little bit of review before we start. If you recall, the circumference of a circle is the length around the circle. So if you were to walk along the edge, that's the circumference. We learned that the circumference is either pi times the diameter, or you could do the circumference is equal to 2 pi times the radius. Then we learned about arc length. We learned this lovely formula here, where instead of walking around the entire circle, you're only walking around a part of the circle. So the arc length is equal to 2 pi r, which was the circumference formula, and then that gets multiplied by the central angle times 360. So it's a way to take a fraction of the entire circle. That's where this formula came from. Instead of it being the length around the whole circle, it's just this part. We're going to do the same thing today with the area of a circle. So if you recall the area of a circle, the formula is pi r squared. That's the only one, the only formula for area. So if you want to find the area of a sector, it's the area that's between two radii in a circle. Notice it's going to look very similar. So the area of a sector is equal to pi r squared, the area of a circle, times the fraction, the central angle over 360. That way we get a fraction of the entire area of the circle. So notice these formulas looks almost identical. What's different is this part right here. So notice this is circumference because it's part of the whole length around the circle. And this part is area because it's the area of part of the circle. So make sure you're using the right formula if you're finding arc length or the area of a sector. So number 1 says to find the area of the sector formed by angle ACB, leave answers in terms of pi. So we're trying to find the area of the sector, so we're going to write down our sector formula. I don't know the area of the sector. We leave the answers in pi, so the pi is going to drop down. Our radius in our circle is 10 inches, so we're going to plug the 10 in for r, and then that's being squared. This will be times what our central angle is, so the angle of this sector is 60 degrees, out of the whole circle, 360. All right, so from here, we're going to type it into our calculator. You're not going to plug the pi in, but you're going to plug in the 10 squared, and then parentheses 60 divided by 360. So it's going to give us a decimal, which I'm going to convert this to a fraction by hitting the math button. And then we're going to do enter for a fraction. So it'll turn the previous answer into a fraction if I hit enter. So I'm getting 50 divided by 3. You always put the number first, then the pi symbol, and then whatever the units are. So this is inches, but because it's area, it's inches squared. So that is our answer. The number, then pi, then units. And the units are squared for area. All right, go ahead and give number 2 a try. We're going to find the area of the sector leaving answers in terms of pi, and we're using our sector formula. Okay, so we're solving for the area of the sector. The pi is going to drop down. The radius is 4 feet. The central angle, the angle of our sector, is 90 degrees, and that's out of a full 360 of the circle. All right, so then we're going to type this into the calculator. We don't plug in pi, but you have 4 squared, and then parentheses 90 over 360, and hit enter, and you're getting the whole number 4. And that gets you 4, drop down the pi, and that's feet squared. All right, number 3, it says to find the area of the sector rounding to the nearest tenth. So this time it doesn't tell us to leave the answer in terms of pi. We're supposed to round this time. So we're still using the same formula because we're trying to find the area of a sector. So that's the unknown. Notice part of our circle here is missing. I don't know the angle of my sector that I'm trying to find. If you notice, this is a semicircle. This is 180 degrees. So to find this missing angle here, you would do 180 minus the 72 over here and get that this is 108. So that can fill us in here. Notice we also need to know what the radius is. They're giving us the diameter is 10, so that means our radius has to be 5 and 5. So plugging it in, we have pi times the radius is 5 squared. And then the central angle of the part I'm trying to find in the circle is 108 degrees out of 360. All right, so we're going to type this into our calculator. This time I'm plugging in pi because I'm not leaving the answer in terms of pi. So on your calculator, you would go second, and then over here is the pi symbol. It's the little caret button that has the pi in the blue. So now I've got my pi. And then we have parentheses 5 squared. And then we're doing 108 degrees divided by a full 360 in the circle. And then we hit enter. And since I'm rounding, I'm not going to make this a fraction. I'm going to leave it like this. And that's units squared. Notice when they don't give us the units, we just use a U. And then this is squared because it's area. All right, number 4, finding the area of a sector rounding to the nearest tenth. It's your turn using this formula. Go for it. Okay, plugging the information in, notice you had to find the central angle of the shaded part. So if this part is 250 and the whole circle adds to 360, that would mean that this part has to be 110. So this was 250, so 360 minus 250 gives you 110. So when you plug it in, it's pi times the radius in the circle was 8 squared. And then the central angle of the shaded part of the circle is 110 degrees out of 360 degrees. All right, we're going to start typing this in. We are plugging in the pi because it does not say to leave it in terms of pi. So we go second pi, and then we have 8 squared for the radius. And then our degree is 110 divided by 360 degrees. And we're going to get this value, and we're rounding to 1 decimal place, so it should be 61.4. All right, number 5 says to find the radius of circle S, so that means S is the center of our circle. Notice they're giving us the area of this sector, which means I have to find the degree of this sector. So if this is 60 degrees, that means this shaded part has to be 300 degrees, so it adds up to 360. And we're going to use the same formula, but this time we're given the area of the sector. So we're going to plug in 30 pi for the area of the sector. And then I don't know the radius, so this pi r squared has to drop down. And then the central angle of the shaded part is 300 out of 360. So now we have to get r by itself. It's going to take a little bit of algebra here. Notice that on both sides of the equal sign we have pi, so those are going to divide out. And then to get rid of this fraction, I should multiply both sides by 360 degrees. That'll make the 360s cancel on this side. So now I have 30 times 360, which is 10,800. And then on this side, we're doing r squared times 300, so it's 300 r squared. So we would divide both sides by 300. You're going to get 36 equals r squared. To get r by itself, you're going to take the square root of both sides. So the square root of 36 is 6. So our radius is 6. If the area was feet squared, then the radius is just 6 feet. All right, go ahead, try this one. Okay, plugging in what we know, the area of the sector is 40 pi. We don't know the radius. The central angle of the shaded part is 100 out of 360. The pi's are on both sides of the equal sign, they divide out. Multiply both sides by 360, so the 360s cancel. You have 360 times 40, which is 14,400, equals, you're doing r squared times 100, so it's 100r squared. Divide both sides by 100, you're going to get 144 equals r squared. And then square root both sides, you're going to get 12. The units are meters squared, so for your radius, it's just 12 meters. All right, number 7 says to find the central angle to the nearest degree. So notice I'm not given the angle this time, but I have the radius and I have the area of the sector. So this is the formula for the area of a sector. I can plug in the area is 5.8 this time, and then drop the pi down. The radius is 5, so this will become 5 squared. But this time I don't know the central angle, so I'm going to call that x over 360. That way we're solving for the central angle. So we're going to use some algebra to figure this out. So I'm going to combine this together on the right side. So we have pi times 5 squared is 25 times x, and that'll be over 360. So this will drop down, and this will become 25 pi x over 360. So to solve for x, I'm going to multiply both sides by 360, so this cancels. When I multiply this, I'm going to get 2088 equals 25 pi x. I can divide both sides by 25, and you're going to get 83.52 equals pi x. Then you divide both sides by pi, so you're going to get 26.59. Now let's remind ourselves what we're doing. We're trying to find the central angle to the nearest whole degree number. So this, as a whole number, would round up to have a central angle of 27 degrees.